yeah, we can discuss questions.
Thank you for this interesting talk. So far, we don't have any questions in the YouTube channel. If someone wants to ask a question, please write them in the chat. In case there are no questions, maybe we'll just let you guys continue with the next talk. And if some questions come, we'll just take them and answer after the next session.
Yeah, sounds good.
Thank you very much.
All right, can I start?
Yes, please.
Let me share my screen. So, hello everyone. My name is Abdurrahman, and I'm going to give you a quick overview of coding for ML. It's going to be a very dense tutorial, so I'm trying to give you an overview on as much things as I can, so I can go slightly faster in some slides. So here we go. So this is what we're going to cover. So we're going to have a very quick overview on what is Colab, and then go see what's popular Python libraries we usually use, and then have a short introduction to Hugging Face library, and then show some tools that we usually need when doing coding. So first on Colab, let me just start a slideshow. So Colab is a cloud-based Jupyter notebook. If you don't know what's a Jupyter notebook, it's just, you can consider it a web-based IDE. If you don't know what's an IDE, we will know it near the end. So it requires no such setup, and it can be accessed directly from your browser, and it provides a limited CPU access. So we're gonna cover these points now, like how to upload file, how to mount your Google Drive so you can use the data you have on your drive or save stuff, how to install libraries in Colab, and how to use command line. So let's quickly go to the Colab tab. So to mount your drive, you can simply just import drive from Google Colab and then mount your drive. This line takes care of it. And it will prompt you to enter your allowed access to Colab and so on. So I already mounted, so it doesn't show now. For uploading, you can see like this little button opens directory that you have in Colab, and then there is the upload button. And you can upload any file in Colab. And the files will vanish after you close your session, so make sure you save them if you want. And able to read the file or use the file, you can easily just copy the path and use those files. You can use in Colab the commands you can normally use with your command line. Usually you need to add the magic character and then use the command you want. So for example, cat, to see what's inside the file I just copied. So yeah, so you can see the file. And you can upload any files and use them the same way. You just copy the path and add them where you want. Second thing I want to add is how to install libraries. So normally, as you do in your command line, you just can pip install whatever libraries you want in Colab, and it works just fine. Just make sure you add the exclamation mark before it. And you can just install any libraries in Colab. As I was saying, you can also traverse your directories using the normal command lines you use with your command line. For example, if I want to move to see what's the current directory, let's just pwd, which is show you your current work directory. Sorry. So this is my current work directory. I want to go to the Google Drive directory, so I just use cd and drive. And now I have access to all the files on the drive. I can just ls, and I can see all the files I have on my drive. Another thing you may need in Google Colab is just if you want to clone some repo to use it in your code, you do it as you do it in the normal command line. Just add exclamation mark and get clone and then the repo you want. For the GPU access, you change your runtime from here. You go to runtime, change your runtime type, and then you can either use CPU or GPU. GPU have a limited access, which is usually like 12 hours, so don't abuse it. Like just use it when you need it. When you don't, go back to CPU. All right, so this is a very quick introduction to Colab. Let's see what's next. All right, so Python libraries. So I'm gonna cover the most important Python libraries here. It's gonna be just a quick overview since we have little time, and I will have the documentations at the bottom of each slide. An advice is just like have a quick overview on the important libraries from the documentation, and then ask ChatGPT. It's the best teacher you can ever have for this kind of stuff. Just ask it about any function you don't understand, and it will be very quick and easy to do. And also, if you're not familiar with Python as much, this is a very nice tutorial that you can access to refresh your Python knowledge. All right, so let's start with NumPy. So NumPy provides support for creating and manipulating arrays and applying wide range of operation on them. You can do dot product, you can inverse a matrix, you can do a lot of stuff. It's just like whatever you need to do with a matrix, you can do it with NumPy arrays. And it's fast compared to normal Python because it's written in C and it's just wrapped with a Python wrapper. And the data type it uses is called ND array. So if you have a check dot type, this is your variable encoded ND array, so you're using a NumPy array. So the key features, it can be easily casted to and from any other data type. So you can go from list to NumPy array, from NumPy array to an image, from image to NumPy array. So this is one of the very cool features for NumPy arrays. This can be intermediate to go from one data type to another. Broadcasting, it's like automatically broadcast your variables. For example, if you have an array and you added a scalar to it, just like an array of 4 elements and you add 1 to it, it will just expand this one to be an array of the same size and add the one in each element of the array. So this is broadcasting, and it works in every dimension. Last thing is vectorization, is that one of the benefits of using arrays just it vectorizes your code. For example, if you're doing neural networks and you do like WX plus B, instead of doing it for each data point, you can just put all your data points in a vector form and then do it in one go instead of using a for loop. So this is vectorization, just changing a for loop to just a vector or a matrix and just do the operation you want on it. All right, so the second library we were talking about is SciPy. So SciPy extends the functionalities of NumPy with mathematical algorithms and some useful functions. So it have linear algebra functions. For example, you can do eigenvalues, eigenvectors, and so almost any linear algebra operation you can think of. You can do statistics operation, for example, getting the p-value and probability distributions. And you can do signal processing with it, like filtering a signal. It's not very useful library nowadays because most of the functionality you can get it from the following library, but I just wanted to show there's something called SciPy. So the next library is scikit-learn. So it's just a better SciPy. It's built on NumPy and SciPy, and it has tons of machine learning models, and it has a lot of data sets. It's really good if you're doing basic machine learning stuff, not deep learning, like just machine learning things. So it has libraries for implementing and evaluation of machine learning models. So it has a lot of models like Bayesian, logistic regression, linear regression, and so on. And it has evaluating tools that you can use to evaluate your model. And it has data processing and feature engineering libraries that you can play with your data, so like normalize the data and so on. And as usual, like the documentation is down there. It's a really nice documentation. So I will recommend the documentation as we go on. So I recommend reading NumPy documentation and scikit-learn. They are super easy and super useful and super easy to like follow. All right, so the next one is Python, Pandas, Python data analysis library. It's a data analysis and evaluation tool, also built on top of NumPy, which means it's fast. Since NumPy is written in C, it's the same. The data type it uses data frames and series. Both are tabular form. Data frame is just column and rows. It's like an Excel sheet, but like in Python. And series is just like a kind of a vector, like one row of a data frame. So data frame is multiple series. And you can use it to load almost any type of data. You can use it to JSON file, CSV, text, or Excel sheet, anything. You can use it for pandas. Like it's really nice in this regard. So the key features, you can use it for data cleaning. You can handle missing data with it. It has like some functions you can use to handle missing data and remove duplicated entries and so on. You can do data transformation with it, merge a data frame with a data frame and join them, concatenate them, and everything you can do is SQL. You can do it in Pandas data frame, which is super cool. And lastly, you can do the data wrangling. It's just like having some random data that you want it to be in a decent format. You can use it later for your model, training your model. Also, Pandas documentation is quite nice, but I wanted to show like some of the most used things in Pandas, like personally speaking. It's just like reading a file, CSV file, Excel, and this should be read underscore JSON, just read a JSON file. And data frame.head. So we called our variable data frame. So df.heads just show you the top entries, info showing you the information is like how many data you have and so on. Describe show you statistics of the information is like what is the mean of certain column and so on. If it have null values, it's really nice to see what's wrong with your data. And also you can filter your data on specific conditions. Like I want the data that have only the, for example, having, if your call name is age, having people with age more than 10. So you can just isolate your data and do specific operations on it. So the next library I'm going to talk about is Matplotlib. So this one is useful for visualization if you want to look at your data, because looking at data with your eyes is just some values is super hard. So you can use it to visualize data and you can create nice figures with it. And it's simple and have wide support online, so you can always find what you need online in this one. Also, ChatGPT is super useful in it. And the documentation is quite nice, but it has a lot of things that can be tweaked, so I would recommend using ChatGPT for this one. All right, so the next library is OpenCV. So it has a comprehensive set of tools for computer vision applications. This was the best thing after slice of bread before the era of deep learning. It was doing fancy stuff in the computer vision section of life. So this was a go-to. It have function for image manipulation, filtering, age detection, picture extraction, and morphological operations, and so on. It also have tools for motion detection, object tracking, and background subtraction. It was like the best thing ever. It was like you can have everything you can do in an image. And also it has a 3D stuff like camera calibration and 3D reconstruction. So key features, it has almost any machine learning algorithm you can use for computer vision, for example, face recognition algorithms, object detection algorithms, and augmented reality. Yeah, life was fancy before deep learning, but not as fancy as now. And also it have deep learning integration with current frameworks like TensorFlow and PyTorch. So anyway, so scikit-learn is like have general machine learning algorithms. OpenCV is focused on just computer vision algorithm. So the next library is Pile. So it's used for image reading and navigation. It has a data type that's called Pile. So if you check your variable and the type is Pile, you're using Pile. And it's directly compatible with PyTorch and other libraries. You can literally like directly use this data type and pass it to PyTorch and it will not complain. So this is the most used command for me with Pile is just like image open. It's just like usually used to open the images in your dataset class or just do some simple manipulations on it. The tutorial is super long, so I would just say stick with ChatGPT with this one also. And for OpenCV, I don't think you would need it much with deep learning nowadays, but whenever you wanted to work on low-level machine learning, low-level computer vision, you will need it. So like don't approach the OpenCV documentation until you really need to do some low-level stuff because it's super big and super complicated. It's straightforward, but like there's too many functions and classes in it. All right, so the next library we have is NLTK, Natural Language Toolkit. So it's OpenCV but for language, but it's slightly less overwhelming than OpenCV. So it has a suite for text processing libraries. You can do tokenization, you can do stemming, you can do lemmatization, and so much more with it as text processing. And you can do other stuff like part-of-speech tagging and syntactic parsing. And you can also do semantic reasoning. So yeah, before deep learning, there was actually some work on language, but like it boomed when transformers happened because the accuracy was not that good and we didn't have a generation model back then. So the key features, As I was saying, OpenCV is having a lot of vision algorithms, and NLTK have a lot of NLP algorithms. So it's focused on NLP algorithms. So you can have like your naive Bayes and a lot of other NLP algorithms used for classification, clustering, and so on. It has a lot of sentiment analysis, pre-trained stuff, and data sets, language translation, and information extraction. And to train the stuff, you have over 50 Cobra and Excel resources you can load and play with. NLTK is useful nowadays also because you can do the pre-processing on it. And if you want to play with low-level stuff that doesn't require GPU, this is your go-to. It's slightly less overwhelming than OpenCV, so the documentation is nice. All right, so we finished the pre-deep learning era. Now we have deep learning, so we're using PyTorch. So PyTorch is an open source library developed by Facebook. It's widely used in academia, and it's currently getting more popular in industry. It's catching up to TensorFlow, which is interesting. TensorFlow is like the best thing in industry, but now PyTorch is going there. And it's Pythonic. This kind of are related now because TensorFlow 2 is also Pythonic now, but like back in the days, TensorFlow 1 was super hard to play with. It wasn't like as intuitive as now. So yeah, like it's still a feature. It's Pythonic. It have intuitive syntax. It looks like Python code. And they have huge community support, and it can be easily integrated with a lot of popular libraries. So the key components we're going to talk about is first, the data type of your PyTorch variables are tensors. So tensors are basically NumPy arrays, but for GPUs. So it's just like, it behaves very similar to NumPy array, but it just can be used with GPUs, so that's why we use tensors. Sometimes you would like to use your tensors with CPU, so you just move it to CPU and play with a NumPy array. So this is a quick tip. PyTorch have computational graph and autograd, so it creates the computational graph for your code, for your model. So it calculates the weights for you and does the backpropagation, the partial differentiation and stuff. It does everything for you in the background, and you just click one line of code and you have your model's output done. So pretty cool. It uses something called dynamic graph, but it's not related now because TensorFlow 2 now have also dynamic graph. So the difference between static graph and dynamic graph, that static graph, you create everything at the start of creating your model, and then you just do it once and you can't change anything. Dynamic graph, it works as you go through your code. So you can debug like you can see the output of each part of your model and play with it without having any errors, but static graph, you cannot do that. It has data sets, which is your class that you create your data sets on and you give it your model. It has a data loader, which loads your data set into your model. And finally, we're gonna see how training looks like. So this is a very quick code for PyTorch. So transform is just like a library that you can use to apply transforms in your data. Usually used in computer visions, like add normalization, add some kind of segmentation and stuff. Transforms use this. Train set is like, I'm just loading a data set from the repo. Train loader, this is how you created train loader. You just load it from torch.utils with data loader. So this is your data loader, and you give it your data set, batch size. And if you're training, you want to shuffle your data so your model does not see the same class over and over at the start. It's really bad. It will cause a really bad behavior. So here is where you define your network. So you need to inherit from your nn.module, which is the base module for PyTorch. And nn.linear will give you like create a linear layer for like just a linear layer. To create a linear layer, you need to call nn.linear. So this is the first linear layer, and then we were making an MLP, so we'll create another linear layer. So this is just a simple MLP that can be used for classification. It outputs 10 classes. And you have your forward path. This is what you want your model to do. So I want my model is to take an image and make it expand it and path it to 2 MLP layers. This is a bad approach. It's not seen in just an MLP, but like, yeah, it's just showing a demo. So you take your image, flatten it, pass it to the first fully connected layer, and then applying a activation function. And then you have your first FC1 done, your first fully connected layer, and then you pass your output again to the second layer, and so on. So if you have multiple layers in your model, you can just take the output of one model to give it one layer to give to the next one, and the next one, and the next one. All right, so we have only forward path. So where is the backward path? As we were talking about, the computational graph takes care of it. So you just define the forward path and everything is taken care by PyTorch. So we create an instance for our class, we call it net. You need to define a criterion, which is the loss function you're gonna use. For us, we're gonna use cross-interval loss because it's just a simple classification task. And the optimizer, you need also to specify the optimizer. Here is just SGD. So PyTorch have all the optimizer in torch.optim. You can have Adam, SGD, whatsoever you're gonna use. So here is a simple training loop. You take your train loader that you just created up there, and you get the inputs. You take the outputs you give. So here we have only like an images that have like features and labels. So we take the inputs and labels from our train loader. You first zero grad your optimizer, so it doesn't have gradients from before. You give your inputs to your network you just created up there. You calculate the loss using your criterion you just created up there. Loss the backward. This is the backward, the autograd I was talking about. Just one line, and you're done with your backward. And then you optimize the steps to update your model's parameter. So we were talking about the dataset class. So this is the dataset class over the hood. So before we just was loading the dataset in the train loader, and then just some two variables came up. So this is how it looks from the inside. So you have your get item. This is what it gets called when you have your data loader calls. So this is a simple dataset, just returns a text and a label. And this is what we get rid with your data loader. Also, there's something called class function where so PyTorch data loader expects everything to be the same size. So sometimes when you work with text, you have different sizes and you want to do some padding. So usually you do the padding in the collab function, where you take the outputs you take from the get item, and then you just do whatever you want with the padding and then pass it again. So collab function just takes a batch, and then you apply operation on it and give it back to the data loader. Normally the collab function is empty. It just returns what the get item does, but sometimes you need to do a custom class function. So there is also like tutorials that explains whatever I said now, which is easy to follow. So yeah, next. Now, Hugging Face. So Hugging Face is basically GitHub for AI models. So you have a repository that have 100,000 of models up there. It's open source and anyone can contribute to it with datasets, models, and checkpoints. And it has a straightforward pipeline that makes loading, training, and using pretrained models a breeze. So Hugging Face also have a datasets module, but the difference between this one and the previous one, this one just contains the datasets and you can apply operations on it, but still it inherits from the PyTorch dataset module. So you can use this one directly, or you can create your custom dataset, and you can have different ways to do the same thing a lot, usually. It has a evaluate modules. It has also the transformers module, of course, and the diffuser. We're gonna discuss these ones now. And finally is pushing to the hub and committing to the community. All right, for datasets class or module, it contains large amounts of public datasets, and it continues to grow thanks to the community who keep pushing new datasets every day. Allow easy and optimized processing of the pre-processing of the datasets. So you can do everything outside you. So yeah, like basic functions, you can always do them directly do them outside without relying on creating your own custom dataset, which is nice. Sometimes if your pre-processing is easy. So it's very simple to use. Just upload the datasets, the load datasets from your datasets, and then you specify the name of your dataset. For example, IMDb and whatsoever. You can find the datasets on the hub. Whatever dataset you want to use, you will find it. Just search for it. And here I was saying you can do simple operations on the dataset. Just define a function, and you want your maximum text to be 50, and you can just use dataset, the one you just loaded with filter, and apply a function you want. There are also dataset.map, and there's several things you can do with the datasets. Here's another example that uses dataset.map. Which I want to add padding to all my datasets. Instead of doing the stuff I was talking about, like custom dataset, collab function, and so on, here you can just do it in one line of code. Just define your tokenizer and dataset.map. Yep, you have everything done. So it's pretty convenient if your high-level stuff are easy to do. But if you're creating a dataset from scratch, you need to use the PyTorch fluent because it's allow more control over what you can do. All right, next is the evaluation. So Hugging Face also provide access to a wide range of evaluation tools. And it can also be used for visualizations, but I don't really recommend it much. So everything is under the evaluate class. So you'll have a lot of metrics. You can just evaluate .load and your metric you want. There's accuracy, precision, recall, F1, there is rouge, there is blue, there is cider, there's most of the evaluations that you would need. And it's very easy to use. You just have your normal training loop. And when you have your predictions, you add, like, you use the object you just created from the evaluation, and you add batch by batch. You give it the predictions you have now and the targets that should have done, and you keep adding the batches. And after you finish, you just call accuracy.compute. Another thing, you can just have a list that you can append everything to it and put the list eventually. This also works, but I think this is easier to use. Here's also a quick guide tutorial about what kind of evaluation codes is there and how to use them. Hugging Face tutorials are super easy to follow, honestly. Like, it's quite intuitive and have really decent examples. All right, next. Now for the transformers library. So the transformers library allow access to a massive number of models based on the transformer architectures and checkpoints. Some of them are official, released by the creators of the model, and some of them like just community contributed. So it focuses on tasks related to text classifications, question answering, image captioning, and text generation. And this is how you can use the transformers library. So transformers have submodules, so every family of models have a submodule. For example, you have BERT tokenizer, you have BERT for sequence classification. So you have some for BERT, some for GPT2, some for T5, and so on. So how do you know which one to load? You check the documentations. We will quickly have a quick overview of the documentation in a few minutes. So you load the correct family, the correct submodule you want from transformers, and you just simply use the submodule from pre-trained. You get the pre-trained version, and load its tokenizer, and also load its model. It's very easy to know how to load them. I will just show you. It's super simple. You don't have to memorize anything. Here we create a data set as we just did, and do tokenization as we did, and so on. So for training with transformers, you have two options: either to use the normal PyTorch loop, where you define everything yourself, or just use trainer. So in transformers, there's something called trainer, which just can take care of everything for you, just giving it the training arguments, what arguments you want to use, and you just give it the model and the arguments and the data sets, and it's just do everything for you. It chooses it does a backaggregation, it computes the loss, it gives you back the loss, and so on. It just does the entire for loop for you, like the basic for loop for you. I don't like it, to be honest, because I like to play with my for loop a little bit, so I usually use the normal for loop, but it's preferences. Here I want to show like how do you do a custom model. So for example, here I loaded BERT, and I want to use BERT for classification. So I create a class that inherits an input module, as we have shown the simple model that we showed before. And the init, I will just get our BERT model from the hub, and I want to add a linear classifier to it. So I just want to know what is the hidden output size of the BERT, and then I want to have a simple classifier on top of it. So it's very simple. I just get the output of the BERT. I call BERT as I would call it normally, and I just add the linear layer I want. So when you call BERT like this, the outputs, you will have several things. You have the input IDs, the output IDs, and you have the logits. So that's why you use the first one, which is the logits. And here we are just adding a dropout to avoid overfitting, and just the classifier just created over there, we give it the output of our BERT, and we return the logits. So they're very simple to use, like a pre-trained model. You just consider it a layer, and then continue the model as you want. You can also use some specific layers in it, because Transformers is modular, so everything is in module, so you can just pick part of it. You can print the model and pick specific parts of it. And here I wanted to show a generation example. So I'm using GPT-2. So as I was saying, everything have a submodule. For GPT-2 is called GPT Tokenizer instead of BERT Tokenizer, and it's called GPT LM head model. I'm loading both from the hub, adding it to a GPU, and to give an input, you need to encode it first with the tokenizer. So once upon a time, I wanted to continue a story. So I just use a model to generate. So model to generate is what you use to give an output for your autoregressive model. You give it the input IDs and the maximum length you want, and then it will give you tokens. You just use tokenizer to decode the tokens into actual words. It's very simple to use generate also, generation models. And yeah. All right, so next. So after we talked about transformers, we have diffusers that we discussed. So diffuser is similar to transformers, but it contains publicly released diffusion models. And it focuses only on image generation tasks, unlike transformers, which more towards text generation. So similar to transformers that have submodules, diffuser also have submodules. The main ones are just the diffusion pipeline and the scheduler, as it was discussed in the presentation before me. So we simply we're gonna have a diffuser for CFR10. So we just load a data set that called CFR10, which have like small images. And we wrote our model from the hub as we saw with the transformer just from pre-trained and the name of the model. And we load a scheduler and decide how many denoising steps we want. And you have an optimizer and you create your data loader as we showed before. And this is how you can use a for loop instead of trainer. It's just a simple for loop. And you take your images and you have a random time step from the scheduler, pass it the image, and then you have your loss. It's just like very simple, like exactly how you saw the pipeline going in the presentation. This is exactly what you do in the code. You just get a random time step, you give the model with the time step, you get a loss, you do loss backward. And everything is predefined in the pipeline, so you don't have to define your loss function or anything. All right, so let us have a quick look on how the documentation looks like. So here is so here's the BERT documentation. So this is the BERT I was using. You can look for the documentation. It shows you everything in the function you're using. It shows you what config you can give it to your model. Is like you can change the vocab size, hidden size of the fully connected layers, number of hidden layers, and so on. And it shows you like sample codes of like how to do each step. So instead of looking at like the default model, you can change the configurations and so on. So this is the documentation of each model. You can find it for all models like GPT. You can find one for GPT Neo or GPT-2 and so on. And there's something called model card, which shows you how to use this model. So here's like gives you an example of how to use the model and also how to load the model. So you just click use this model, transformers, and it gives you the 2-line code I just showed you. It's very straightforward. Also the same for the diffusers. It has the same idea. It's like it has a documentation that shows you what you can do with it, and different models with different model cards that shows you how to use it and how to get the outputs and so on. So the documentations are very essential to do. You can look at model cards here, and the documentation you can access it from the documentation. It's like just Google like Hugging Face documentations and whatever model you want. All right. So now, right, I'm getting outside, right. So pushing to the hub. So after you train your model, you can contribute it to amazing community we have, which just these lines of code. You just get a token. So when you create a Hugging Face account, you have in your profile a token, you just paste it here, you log in, and then you push your model to the hub. Like model to push to hub, and then the name of your username and where you want this model to be called. It's like similar to GitHub. You can also use the GitHub commands, but like I think this is easier. And there's also a tutorial how to upload your models, and it's straightforward. All right, so now we finished with deep learning. These are quite essential tools you can use. You will need them while working. And also this link have a very nice something called the Missing Semester. It was created by MIT like a few years ago. It covers a lot of stuff that you will not be taught in the university or school or whatsoever. Like how to use a debugger, how to you like version control and so on. It has really nice stuff. You can have a look at it. All right, so we start with Python debugger. It's built in Python. If you download Python, you have a debugger directly. You don't need to download it or install it. It's better than using print. So debugging is want to know what's wrong with your model. So one way you can do is just print in every single step in your code. You just have a print statement to see if you're going right or wrong. It's not that good. So cool kids don't use print, they use a debugger. And it works everywhere. Like you can use it in command line, you can use it in IDE, you can use it everywhere. So it's quite important tool. So the core function you can use with debugger is breakpoint. This is where you put it in your code, where you want your code to stop, and you start seeing what's wrong with your code or the outputs and so on. So the most important debugger commands are continue. It will run your code until the next breakpoint. Next, we'll run the next line. Interact. If you want to run multiple lines in your debugger, you just click interact and you can, like, for example, run a for loop. Because without it, you just have to run line by line. You can't copy a chunk of code and paste it, for example. And finally, break is the exit execution. Here's the documentation, but it's super annoying to follow, to be honest. So I don't think you will need anything more than these commands. So the second thing I want to talk about is IDEs. So integrated development environment. So before IDEs, people used to use Vim, which is the default text editor in Ubuntu, and life was not easy with Vim. Like it's not a nice thing to use. It's like using docs for programming. It was really nice, sad, but it looks cool. Like when you see someone working on Vim, it looks very cool. It feels like they know what you're doing. So IDEs makes life easier. It has colors, it has syntax check, and it have autocomplete. It's a really nice thing to have. And it have interactive debugging. So instead of just running line by line, you can have an interactive debugging with seeing your variables and everything while still in your debugging session. Because in the normal Python debugger, you can't see the variables, you have to print them. And finally, it's easy to integrate with other tools. For example, you can use GitHub easily with IDEs. You can Copilot, which makes coding like what takes an hour takes 30 minutes. It's quite nice. So examples of IDEs, Visual Studio Code and PyCharm. Here's a link for both of them. It's personal preference what you want, but both are equally good. The second thing I want to cover is Anaconda. So it's a package and environment manager. So some codes require specific packages and libraries. So this helps having different environments for each code you have. And it takes care of dependencies. So some libraries require a specific version of other libraries. So Anaconda takes care of this, just like matches every library install with other dependencies you have, which is super cool. It's slightly slower than Python Wheels, but given the previous two benefits, it like the bros out carries the cons. It's not that bad, like, but Python Wheels are slightly faster, honestly. So next is weights and biases. So it's a fancy logging tool. You can keep track of your logs of different experiments in it. It's web-based. You need to create an account for it. You can monitor your model across different experiments and creating figures for different parameters. So what's cool about it, you can push different models you have, and then you compare all your models. For example, you want to see which learning rate is the best for your model. So you run different models with learning rate, and you upload the results to weights and biases. You can just visualize the difference between different experiments. And it's very easy to add to your code. It's just a few lines. You just use OS.environment and give it the weights and biases key you have. You get it from your account that you create on weights and biases. You give it a config, which is like just, this is the config is just literally for you. It's just a dictionary. You just mention the parameters you were using for this experiment, so you can see it later. And you just say with weight and biases that you just import WANDB, and then with WANDB.init, and then the name of your project and your config file. This is optional. This is to watch your model parameters and everything. It's not that important. This is the important part. is to log the training loss you have, the validation loss, the accuracy, and so on. So you can have some like useful statistics to compare to your model. All right, the tutorial is super nice, and this is some example for how it looks. So you can see you can compare two models and how they like fare in front of each other. You can see how your learning rate is going and so on. Super nice tool. It makes life easy to like see the best parameters to use. All right, so finally, the last thing we have is GitHub. So GitHub is a version control, which is a fancy word of saying that it saves all the code changes you have. So you can have several different files from the same project. For example, I have a project that I wanted to change some specific functions in it, but I was afraid that it will break the code. So I will just have a version of this project without these functions and a version of this function. So that's what's version control called. You can just keep tracks whatever you're doing. You keep pushing your changes. It makes collaboration very easy. Someone else across the globe could be working on your code, and you just keep pushing to the GitHub and you see what changes you made and fix it together. It's super nice for collaboration. And it helps keeping track of experiments. So you can have different changes on your code one after another without losing your previous experiment. So the basic ones you would need as git init, just start your GitHub repo inside your file. Git add is if you want to add all your files that you changed in your current project, just git add space dot. And if you want to use a specific name, you just say the file name, or if you don't want to add extra files, just want to add the changes to the files you already added before, you just use u. Git commit, if you want to commit to your current code, which is just saying like, all right, this is the changes I wanted to make, and this is what I did, and you put a message. So now you have committed the stuff locally in your temp file. So if you want to push them into the GitHub repo online, you use git push, which puts your changes online on the cloud. Now, whatever you can later pull it if you want. Oh yeah, and GitHub like requires you to create an account, of course. Git pull is getting the changes from the repository that you have online. For example, if you're collaborating with someone and he did some changes, you need to do git pull to get the changes back to your local machine. And git fetch also gets it's more general way of git pull. Just it fetches all the branches on the repository. So git pull like pulls a specific branch, and git fetch pulls everything. I didn't mention what is a branch. So I was mentioning like you have multiple versions of your code, right? So usually you put every version like every major change on a branch. So instead of just keep looking like, all right, so where did I have this function before? It's in this commit. No, you cannot just like have different branch for different experience you want to make sure on your model, and just load these branches one by one. You just don't need to go back and look at one of the branches like when did you make this change? Because as I was saying, it just keeps tracks of every change you have. This is a very nice documentation over GitHub. You can see it to have more details. And sorry if I was very fast. I just wanted to cover as much things as I can. And yeah. Oh, I forgot to mention git checkout. It's used to change branches. All right. So I'm really sorry if I was fast, and I hope you guys like benefit from this. And if you have questions, please.
Thank you for your talk. So far, we don't have any questions, and we still have time. So if you want to elaborate on some of the topics that you have just covered, you can do so.
So I'm not sure what I can elaborate on, honestly. So
Okay.
if someone like have a specific question of something that I moved on fast would be nice, so they can point it so I can like elaborate more on it.
Just thanks for the very cool presentation in the chat. No real questions so far. Okay, we gave our participants some time to ask their questions, but there are no questions so far. Thank you once again for all your presentations. If you have anything else to say, now is the time to do so. Okay, no questions, no comments. Let's call it a day. Thank you once again, and we'll see each other at the first edition of the Artificial Intelligence Olympiad.